Now let us look at the next example for buckling analysis. Now in this case, we are going to perform a buckling analysis on a 1D model. Now let us go through the problem description first. We have a beam which is fixed at one end and it is subjected to two compressive forces. One of the forces is applied on a portion of the beam of length 50 mm from the fixed end and the other is applied on the free vertex. The values of the forces are given over here. Force 1 and force 2 are both 1000 newtons and they are acting in the compressive direction. The material that we need to use for this type of this analysis is structural steel. We are going to use a rectangular cross section which is of 10 millimeter into 10 millimeter. The total length of the beam is 200 millimeter and length 1, that is L1, is equal to 50 mm. The force on L1 is 1000 Newton compressive and force on the free vertex is also 1000 Newton in the compressive direction. Okay. Now let us perform this analysis in Ansys Workbench. So again I will come to the Ansys Workbench project window. I will add one static structural analysis system. We have to use structural steel as the material, so I am not entering into the engineering data because structural steel is the default material. We will enter into the geometry. Now there is one thing that we need to note over here. The unit is millimeter. Now see, there are two sections, okay? Both the cross sections are same at L1 and at the rest of the area. The cross section of the beam is same, but we need one point in the center which is at a distance of L1 where the force can be applied. So I cannot make the entire beam as one single structure. We need to have a break over here. So for creating such a design, we have a general method. Now let us see what that method is. When you go into sketching, rather than drawing a single line of 200 mm, okay, what we will do is, I will use a polyline, I will draw one line and again I will continue and draw the other line and then right click and say open in Creo. So you can see we have two lines, okay. I'll give the dimensions to both the lines. H1 has to be 50 millimeters and this has to be 150 millimeters, okay. And then I'm going to add one constraint which is a symmetric constraint to this. So this is how I have created my design, okay. Please make sure that you create it in the same manner. Otherwise, you will not get a point in the center where you can apply this load. This is a very important step for this problem. Okay. Now, once this design is ready, now we will create one cross section. So we have to create one rectangular cross section, which is 10 millimeters by 10 millimeters. After which we will go and create the line from sketches. So we have this sketch over here, apply, and we have created the line body. After that we will apply the cross section, which is the rectangular cross section. So this is how we have created our body. We can view the model. So this is how the model is ready. So now my geometry is ready. We will take this geometry into the mechanical window. So I'll double click on the mechanical window. The model is generated in the mechanical window. Okay. Now once the model is ready, the next thing that we will do is we will perform the meshing. So I will use the default mesh settings. If you want, you can make it finer. Okay. You can see the So now the design is ready. Now we will click on the static structural node. You can see over here. You can change the view options from here, whether you want to see the cross section, whether you don't want to see the cross section. Okay. Now, once I click on the static structural node, I will first add the fixed support. I will use the selection filter of a point and just select this point over here. Okay. So this is a fixed support that we have applied. After that, there is one force which is acting at a point over. Now see, this is because that I have drawn the polyline into two parts. I have not drawn one single polyline. I have drawn one over here and the other one over here. Because of which now I am getting a point over here where I have to apply the load. The load value is 1000 Newton and the direction of the load is this, and it has to be in the compressive direction. Similarly, direction has to change. Okay, so my force has been applied. I need to apply one more force at this vertex. It is again 1000 Newton and the direction is this. Swap the direction and apply. So we have got the forces, we have got the fixed support. So these are the boundary conditions that we've got. And now we will solve the analysis. So I'll get the results. Okay. Once the static structural analysis is done, close this window. And now add the linear buckling analysis system to the solution cell of the static structural analysis system. You will see that the data is shared. Enter into the setup. Okay. Now click on the analysis system. Number of modes to find. Here you can also change the output controls if you want to calculate the stresses and strains in the end. After this, you can say solve. So now you will get the load multiplier for this analysis. So my load multiplier is 10 units. That means I need to apply a load of 10,000 newtons to buckle this design. Okay. Now I can generate the deformed shape. Okay. Once the deformed shape is ready, you can also check the deformation, and then I can also add the beam results, and we can check the stresses. Okay, so you can check your answers over here. So this is how we will perform a linear buckling analysis on a 1D model.